Hello, my name is Yang Li. Let's continue for the calculus here. Last video, we discussed about the example 3.1. We were using the formula of the slope of tangent line in this format. Okay, that's fx minus fa over x minus a, limits x approach x to the a. Now we're going to go over the example 2 here. Still the same question, but we're going to use a different definition format of the slope of tangent line, which is this one. Okay, so to help you to view the whole question, I copied it here first. Slope of the tangent line equals to limits x approach, oh no. So this one is this different format, but it's exactly the same, just different format. So this h approaches 0, f a plus h minus f a over h, like this. Now, let's apply this definition to the example 2 right now, okay? Example 2 here like this. So what are we gonna do here? You can see that fx is this one. Fx is x squared, right? But right now you have what? A plus h for the value of the x. So of course, the slope of the tangent line, put it here, okay? Slope of the tangent line will be equals to, of course, still put the limits there, okay? Don't forget that, h approaches 0. In x squared, but x equals a plus h. So that means you're gonna have a plus h squared minus fa. A is 3, we know that. So this one should be, a is here is 3. So this is 3 squared. And this a, we can put it as 3, okay? So this is the 3 plus h. And over h. We don't know the h yet. H is the value approach to 0, okay? Either from the right side or from the left side, okay? So when we have this one, so you're gonna have limits h approach to 0. This one you're gonna use what? The formula to break it down, okay? So remember we have learned the formula in algebra, a plus b squared equals what? A squared plus 2ab and plus b squared. This is one way you can do this one, right? So if you follow this formula, you get a squared, that would be what? 3 squared and the plus a times b and double. So that's 2 times by 3 times h and the plus h squared and the minus 3 squared over h. Of course, maybe some of students may not remember this formula, but you still can do it. Let me show you here. You can put like this. You can go 3 plus h. This is square, right? Means you have 3 plus h times by 3 plus h, like this. And then you go this one times this one is 9. This one times this one plus 3h. And this one times this one plus 3h. And this one times this one will be h squared. And then this is 9 plus 6h plus h squared. You see, this is the same as this one here. 3 squared is 9. 2 times 3 is 6 and the h and the plus h squared, right? So you can do either way. If you remember the formula, it will be faster. But if you couldn't remember, you still can use what we call this method. It's called as what? for your, remember, for your methods. Means for your first, F is the first, outer, inner, and the last, okay? So from here, you can get what? Here, you can see, we can get this one, cancel with this one, okay? So we will get, this is 6h plus h squared over h. And then make limit h approach to 0, right? Like this. And then you can use, of course, you cannot plug in h right now as a 0 now. You know why? Because you plug in h equals 0, here is 0, here is 0, here is 0. Numerator 0, denominator 0, that's not good, right? That's indeterminate. That belongs to 0 over 0 type in determinant. So what we're gonna do is we use algebra factoring skills. We'll factor the h out. We're gonna have 6. So this h take it out. You have 6 left over. This one is the h squared, right? If you take the h out, you have another h left over here. And then we still have limits here, h approach 0. And then you see here, this one's gonna cancel. So you have only what? 6 plus h, and then that will be 6. So we got the same thing as the slope equals 6 of the tangent line, right? At x equals 3. So let's see what the book explained to us here. The book explained to us the same thing here. They put it in here, right? Plug in here and break it down. And then you can get this one equals 6. All right? So this is another way we can do. We can use either definition of the slope of a tangent line. But just remember, I just give you a heads up, is that the slope of tangent line 2 formats will be as the definition of derivatives. Same, you have equivalent 2 formats there, okay? We'll talk this one later on that when we're there. Now let's look at example 3 now here. Remember when you do the study calculus, right? And you're gonna have a lot of chance to practice your basic math, okay? And we need to practice something, so make it perfect, right? So find the equation of the line tangent to the graph of fx. This is a different function right now. Huh? So we're going to use a different function now here. Same thing. They use the first equation, 3.3, right? And you can go by what? fx, you see, fx equals what? This one. So that's why here they have what? This one. Minus f2. f2 means what? Just simply plug in x equals 2. So that's what 1 over 2. See that? So this one just simply plug in, right? So, so you have this now. And the bottom one is x minus 2. No problem with that. Now, let me show you how do they simplify this one, okay? From here, let me show you how do they make the simplification to get this one. Let me put it here. Limits x approach to 2. You have 1 over x, right? Minus 1 over 2. The bottom one is x minus 2 like this, right? Remember, for the fraction, we can do the both numerator and denominator times by the same number from basic math. Huh? We know that if you time both numerator and denominator by the same number, you will not change the value of the fraction. You still keep the same value of the fraction. You just change the format of the fraction, okay? So just like you have 1/2, you can time by 2 to both numerator and denominator, you will get 2 over 4. But 2 over 4, same value of 1 over 2. It's half, right? But the format changed, but the value not changed. That's why they can do this now here. They time both numerator by 2x, denominator times by 2x, like this. So if you do that, why did it pick up 2x? Because that's least common denominator of this fraction on the top there. Okay, so if you time this one to here, x and x cancel. So you will have like this, limits x approach to 2, and this one will be 2 minus the x divided by this one here. We can keep it, okay? We can keep like this, 2x and x minus 2. Now, here, when you have this one, if you plug in 2 for the x, that's not good, because that's where we get 0 over 0. Same thing, that's indeterminate. But fortunately, this one is removable discontinuity. Okay, so what you can do is this. You can go by the top part. The strategy here is this. This part you can write as what? Negative x minus 2. That's the key part. We do some kind of algebra substitution. The reason for that is we want to simplify, okay? So when you get this one, you can get what? The limits x approach to 2. Why 2 minus x equals negative x minus 2? Because you distribute the negative here, that would be negative x. The negative here times by negative 2 is positive 2. Same. Just change the format, okay? So when you got this one, you're going to have negative x minus 2 over 2x x minus 2, like this. Now, here, you cancel, right? Now you can put the x equals 2 here. That will be equals to what? Negative 1/4. See that? That's why I got this one. You see, my work here, if you watch my video here, I can give you the detailed steps to see how do they get one step to the other one. And then when they go from this step to this step, next step, you will use a lot of basic math. As what I always said, that calculus is not hard. The harder part is what? The basic pre-calculus part. That's geometry trick and algebra, okay? Now let's move on here. So we can get this one, the limits, we'll find it, right? Of course, you can use the same thing to find the line now, right? If you want to find the tangent line, the things will be easy here. You can go by, still use the point slope form because of this here, because you have functions 1/2 at 2. So we can find the points now. The point x equals 2, right? But y is what? You just plug in the 2 to here. So you got a 1/2. So that's the point. And then we can use the slope, a point slope form of the line equation. So you can have y minus y1 equals slope. We find slope is this now here. That's negative 1/4. And x minus what? x1. x1, just the 2 here, like this. So that's why they can get this format, but you can simplify. I can show you how to simplify to get this format, okay? They change it to slope instead form now. So what we can do is add by half, okay? So you're gonna have y equals to this one times this one, negative 1/4 x. This one times this one, negative and negative is positive. 1/4 times the 2, you're gonna plus 1/2 and add by this 1/2. Finally, we can get y equals negative 1/4 x and the plus 1. You see? We got exactly the same what they got here, right? So we just finished this video, and the next video, we're gonna continue with this lesson, okay? We're gonna continue cover, this is the graph here they showed you here. So, and next time in this book, they have one coded as what? Check practice. So as the textbook and as I have showed you how to use the definition of the tangent line slope, and then it's your turn to do this check practice, okay? Of course, the next video, I will explain to you how to do this question, all right? Okay, so that's all for this video. So if you have any questions, please let me know. Thank you. Okay, bye-bye.